So the file vim mem_array.c++, this one basically I wrote it to just create an array of 5 elements, and the name of the array is my array, and it is of type integer. So it has 5 elements, and the first element is my array sub 0. The second element is my array sub 1, sub 2, and sub 3, and sub 4. So the last element is whatever you define on the size here is a -1. The first element is my array sub 0. So when you're printing this one, it is just saying that if you print this, the entire array, just for the variable, it will point to the address of it. But if you're printing an element of it, my array sub 0, sub 1, so on will be just assigned. Here, this is assigning some value to array. So I'm defining array sub 0, sub 1. The reason I came to this program is to show you that on your book, it shows the size of an integer as 2 byte large, but here, each of these array is taking 4 bytes long. So because it's an integer type, an integer on this compiler is 4 bytes long. So that means that my array sub 0 is pointing to some memory address, which is 4 bytes of allocation for it. And then as soon as you define to my array sub 1, then it's going to just go 4 bytes from initial my array sub 0. And the same thing here, 4 bytes from the second element. And the same thing here, the 4 bytes from the third element, and so on. So let's just look at it. In order to print the actual value of my array, I'm here using the asterisk. The asterisk in this case is just dereferencing the content of my array. In this case, the first element of my array, the address of my array, if you don't put the asterisk and you just print my array, it's like almost as if you're doing address of my array. So my array will be pointing to my array sub 0, and it will give the address of that one. But if you want the value of it, then you have to dereference it with asterisk. That's the syntax of C++ and C and other programming languages mostly, especially Object-C and C, C++. When they're using this kind of C style, this is the syntax. So this is dereferencing in order to get the value of my array sub 0. When you don't give any sub index, this is the entire array, but the first element of it, which is my array sub 0. So my array sub 0, this is the first element of it, and since it's pointing to an integer data type, whatever the address of that first element, then the next one it will be 4 bytes after that. So in order to show you that one in computer's memory, I use this for statement to actually print out each element of my array sub 0, my array sub 1, my array sub 2, my array sub 3, and my array sub 4. In this case, you can see the address of my array sub element. In this case, if you use the for statement, whatever the data type you use here, in this case, since it's an integer data type, we're going to point to from 0 would be this element, 1, 2, 3, 4. And so we're going to say element of size. But what is size here? I did not use the number 4, because here, or 5. If I did less than 5, that would be accurate. This one would be less than 5 because there's 5 elements, 1, 2, 3, 4, 5. So less than 5 would be 0, 1, 2, 3, 4. My array sub 4 would be okay, but because I said whatever is the amount of this one, -1. But because I used the less than size, I could give the exact size of the element. In this case, I am just finding the size somewhere here by calculating the array size. The array size, you can get this function that's called sizeof. When you do size of my array, in this case, size of my array is going to be, okay, for the first one is 4 bytes, the second one 4 bytes, the third one is 4 bytes, fourth one, and so 5 times 4 is 20 bytes. If I just say, well, the size of my array is 20, that's not accurate. But then I divide that one because of the first one is also 4, so 20 divided by 4, we get 5 elements. This is how you actually get the value of this array size programmatically. And in terms of vectors, when we are discussing later on, you have a function called sizeof, or size of the vector, size itself with a function. On the C also you have length for the string and other ones. Also the string you could have size and so on. But when you don't have those ones, you can just use this kind of calculation. But sometimes this kind of calculation is not a good idea when you're using heap for memory allocation. In C and C++, you used to call malloc and free and other programming languages. I'm sorry, other function calls like malloc, free, and calloc and this and that. But then on C++, you're using new and delete. When you're doing the size inside the heap, sometimes this is not going to give you, if you're passing it, the argument of a function as an array or pointer, then it is sometimes very kind of complex in order to just make sure that you're exactly getting the size of. So it's better programmatically to make sure that whatever you define this size of variable, you just do that one as here, the size. Don't do this. This is just showing you that it works here, but when you're working with new and delete and other ones, you may run into issues if you're calculating this one, because sometimes you may create a new element and then delete it, and then somehow on the calculation that size just got off by some numbers. Now when you're trying to delete, you might delete something that doesn't belong to your program. So it's better to just write this index, the maximum value, whatever you do, because it's a static, it's not dynamic, you just do it on the first time. So if you just don't want to use number 5 here, and then every time you just do kind of less than 5 here, and then you do other places that are being used like here size, and you want to use a variable like size here, you can also create a constant character integer, and then say size, you say const int space size is equal 5, because you define it as a size 5, then you can just put whatever the word size here, and then size here, because that is a variable. Like you could do, instead of that, you could say, for example, const int size 5, size is equal 5. You could do something like that. So it's a constant and it's an integer, the data type, and so on. But and then you just instead of doing this, you just comment this section out. But at this time, let me just do this, and we compile it and run it to show you the memory in terms of the sizing of integer is 4 bytes in this compiler. So when I say compiler, this is a G++ compiler, running on a Linux Ubuntu machine. So therefore, it is 64-bit operating system. You can see it's a x86 64-bit operating system. So an integer is defined by the G++ compiler, in this case, to be 4 bytes long. So I'm going to say G++ minus O mem underscore array, and then mem underscore array.c++. So I compiled it, there was no typos, nothing. I'm going to just run that one and say mem underscore array and just get the output. Remember the first element of this one, if I just do, let me just do head minus, let's say I get like about 10 lines here, just to show you that C++. So you can see the first array is initialized like this, and then when I say int size of that is getting the size, then I want to print out memory address that is my array sub 0. My array sub 0, this one is printing this 10 here. And then address of my array is printing this address. And then have using, because I put a tab, I did not put new lines, I'm going to just say using pointer reference to my array, it is coming to my array, and then it goes a new line character, then it comes to this for statement. The for statement for int I element is there. Let me just now go to the top of this one. Does anybody have a question? Okay, so now we're looking at this for statement, and then I'm going to just look at the printout minus 15, let's say, or maybe 7 for 12. After the first, okay, let's look at 15. Yeah, so right here, you see this for statement. I want to run the output here again and show you that the for statement that is started here, we were right here to explain that part. It says after updating the first element. So the first for element, it says element sub 0, element less than size, which is less than 5, element plus plus, and then print the my array sub 0, sub 1, sub 2, sub 3, sub 4. And this is going through this for statement to print out the address of each one of them, and then also print out the value of each one of them. So this one is it says my array sub 0, my array sub 1. This is another way of syntax and get. If I could have just done my array sub element, or I could do it by pointing to my array and move my memory element, then dereference it. I could do both syntax. And right here, I'm using that syntax. Right here, I'm using that syntax. So, and I see that there's no difference between them. So, but look at it. So when we are printing the array element in terms of the memory address, we're getting these addresses. And then the value of it, a colon, and then the value is 10. The second one is 20, the value 30, 40, 50. But notice that because an integer is 4 bytes long, C0, then C4, then C8, and then CC, this is 12 in hexadecimal. And then this is D0 is 16. So that's how it goes, 12 and then, yeah, 16. So here again, the memory address, when we're printing out my array sub 0, I'm showing up my array sub 0 is having the value of 100 because I changed the value here. So you can change the content of an array value by pointing another value to this one. This value could be another integer or could be another variable. As long as that variable is defined, you could just assign it to this array sub 0 or array sub 1 or sub. So in this case, I'm modifying two elements, and you can see that the first element was 10, but I changed the 10 to 100, and the 20, I changed it to 200. So now my array sub 1 is 200, my array sub 0 is 100. But notice again, because an integer is 4 bytes long, I'm moving, every time I print the address in memory, it is C0 and then 4 bytes later for the next element. The 4 bytes that we're going, because it's consecutive memory location array is consecutive data type, it is C0, and then 4 bytes from that one would be C4. So my array sub 0 is pointing to this address, my array sub 1 is pointing this one. If I'm looking at my array sub 4, 4 times 4 is 16, so from C0, 16 would be D0. And if I'm looking at array index of 3, 3 times 4 is 12, then from the initial one, C0, 12 bytes further, we have the address of my array sub 3.